So, hello there, how are you? I hope you will be very fine, very happy, very healthy. Okay, so I'm here to explain the concept of acceleration in combined motion, especially in these type of questions. Okay, so question is that find the acceleration of m1 or m2, what will be the tension in the spring. So, I thought I hope you have recognized this question. These type of question get asked from rigid body dynamics chapter. Okay, so just have a pause and just have a realization of these questions, and after 1 second, again resume the video and you will get how to solve this question. Okay, so first I am going to explain these questions with proper method, and after then I'll explain this question with shortest trick. Okay, so I will give you shortest method or short trick to solve this type of question. Okay, so observe this question, have a look on these. Okay, and now I'm going to explain these questions. The statement in this type of question is that a string doesn't slip over pulley or moment of inertia of pulley will be given. Okay, and or it can be also said that pulley is rough. Okay, so a string is inextensible and ideal, but remember this type of question because this type of question also get asked in Newton's law of motion. There these a string slip over this pulley, but here this a string doesn't slip over pulley. Okay, so remember this, if a string doesn't slip over this pulley, then the tension in the pulley on both sides will not be same. Okay, remember the concept in this type of question. If this string doesn't slip over pulley, then tension in this string in both sides will not be same. If a string slip, as in Newton's law of motion, their tension at each and every point will be same. Tension, whatever with tension here, that will be the tension this side also. But in this case, tension will be different. Okay, because here friction is acting, or a string is not slipping. So first of all, we have to go through the free body diagram of the pulley and masses. So look at here, what is happening here in this question. This mass m1 can translate only in vertical direction. This mass m1 can translate in vertical direction only. This can only translate, and this mass also can only translate in vertical direction, and this pulley can rotate only. Okay, so we need to observe the motion of all the pulley and masses first. So these masses m1 and m2 can translate only, and this pulley can rotate only. Okay, so for m1 and m2 we have to write a translational motion of equation, and for pulley we have to write rotational equation of motion. Okay, so look at the free body diagram. Suppose this as this mass m1 is greater than m2, so with general observation we can say that this mass will go down and this mass will go upward. Okay, so as if we apply a string constraint here, then we can say that whatever be the acceleration value of m1, that will be the same value, that will be the same acceleration of m2 also. Okay, so suppose acceleration of m1 is a downward, so acceleration of a here, acceleration of m2 will be a upward. Okay, because of a string constraint, because of a string constraint. Okay, so observe, look at the free body diagram of m1. On m1, as it is attached to a string, so here tension will act. Suppose this tension is T1, and 1 mg will definitely act on this masses. Weight of gravitational force definitely will act on M1. So M1G is downward motion, downward direction, okay, and this mass is doing downward motion with acceleration A. And look at the free body diagram of M2. So as M2 is attached to a string, so tension will act, and this tension will not be same, remember. So here T2 will act, and again weight of M2G will act vertically downward, and this mass M2 will go upward with acceleration A. Okay, so here the free body diagram of M1 and M2. Now also this pulley is also rotating, pulley is also in motion, pulley is in a rotational motion. So we have to draw free body diagram of pulley also. Here as this side, this string part is acting, is attached here. So here tension T1 will act on pulley, and this side tension T2 will act, sorry, this will be T2 and this will be T1, okay. And here it is clamped, so suppose any tension T will act on the pulley, okay. Now this pulley is rotating, so as the mass is accelerating, masses M1 M2 accelerating, then this pulley will have also acceleration, and that will be angular acceleration alpha, angular acceleration alpha. Now analyze the situation. What will happen here? As a pulley is not slipping, and this pulley can rotate with angular acceleration alpha. So here the point of contact of a string and point of contact of pulley should have same acceleration, as a string is not slipping. So whatever be the acceleration of point on a string, the same will be the acceleration of point on disc, okay, here and here also same as. So from here we can say that if we analyze this point acceleration and the point on this disc acceleration, then we can say that A equal to R alpha here, okay. So this is a equation, and this equation get used further in solving this question, okay. So A equal to R alpha, remember what it is. Acceleration of mass M1 A is downward, acceleration of mass M2 is A upward, and angular acceleration of this pulley is alpha, and that R alpha equal to A, okay. So I think you have understood up to A. Just have another look and get realized the motion of masses M1 M2 and pulley, okay. So masses M1 M2 is doing translational motion, and this pulley is doing rotational motion only. So we have drawn free body diagram. Now we have to write the equation of motion separately for M1, for M2, for pulley, and we have this condition, and after then writing the equation of motion we can solve this question, okay. So if I'm going to erase this, okay. So for M1, if we write the equation of motion, Newton's second law of motion, okay, then net force equal to mass M1 into acceleration A, okay. So as M1 is translating only, so we have to write translational equation of motion for M1 only, okay. So for M1, M1G minus tension T1 equal to M1 into A. This can be said at equation 2, okay. So for M1, for M2 we can say as it is a tension T2 is upward, M2G is downward, and this M2 is accelerating upward direction, so we can say net force is acting on M2 is in upward direction, okay. Even it is not acting in upward direction, then our assumption will be wrong if this acceleration value becomes negative, if this acceleration value will come as negative, then our assumption will be wrong. It means M1 is going upward and M2 is going downward. Okay, so here we have whatever we had the assumption, according to that we have to write equation. So here for M2, T2 minus M2G equal to M2 into A. Okay, say this is equation 3. Okay, and we have to write the equation of motion for pulley also. So for equation of motion of pulley, check this out. As this pulley will rotate in this direction, it means net torque on this pulley is acting in this direction. It means what? Torque due to T1 is greater than torque due to T2. Okay, so we can write T1 into, for pulley, T1 into R minus T2 into R equal to I into alpha. I into alpha. This is equation 4. And we have alpha, A, T1, T2, 4 unknown and 4 equation. It means it can be solved. Okay, it can be solved and it will have non-trivial solution. It means it will have valid solution. Okay, real solution. So how we can solve these equations? Right, A equal to R alpha, also it is equation 1. So we have to solve this equation, and from here we can find out T1 minus T2. Okay, so from here we can find T1 from equation 4. Write T1 minus T2 equal to I alpha by R, and we can say it 5, or we can say from here equation 1, we can put the value of alpha as A by R squared. So T1 minus T2 equal to I A by R squared. This will be equation 5. Now we can use this value T1 minus T2. So from 2 and 3, look at it. Can we equate this T1 T2 value? So if you do 2 minus 3, if you do 2 minus 3, then what will happen? M1G, or 2 minus 3 or 2 plus 3? 2 plus 3. Okay, so if you do 2 plus 3, what will happen? M1G minus M2G minus T1 plus T2. Okay, so M1G minus M2G minus T1 and plus T2. It means we can write it as minus of minus T1 minus T2 equal to, here M1, we have added these two equations, so M1A plus M2A. So after then put the value of T1 minus T2 from here, equation 5, in equation suppose it is 6, then we'll have the value of acceleration A. Okay, so put the value of this. So from 5 and 6, put the value of T1 and T1 minus T2 here. So we will have M1G minus M2G minus T1 minus T2 is I A by R squared equal to M1 plus M2 into A. Okay, so we can have take this term I A by R squared from LHS to RHS, then RHS term will come as I by R squared into A, and LHS term will remain as M1 minus M2 into G. So from here you can have value of acceleration A and m1 minus m2 g by m1 plus m2 plus I by r square. And if you have a value, if you got the value of a, then you can easily find the value of alpha as a by r, and you can also find out the value of net torque equal to I a by r square on pulley. Okay, and we can also find out the all the value of t1 and t2 also. Okay, so we have found the value of acceleration a. Now realize this result. Analyze this result. A equal to m1 minus m2. Once again I am drawing a figure. Here it will be m1, here it will be m2. As m1 is greater than m2, in general we can say if m1 is heavier than m2, obviously in general observation we can easily say that m1 will go down and m2 will go up. And from here also, as m1 is greater than m2, so this will be positive, all terms are positive, it means a is positive, a will be positive. If a will be positive, it means our assumption is right. Okay, so we can find any other parameter t1, t2, alpha, net torque, okay, by using this result also. So alpha equal to a by r, and net torque on pulley, if it get asked, net torque on pulley equal to tau equal to I alpha, so I a by r also. Okay, now here I am going to analyze this expression. Okay, and by analyzing this expression we can easily find this expression without writing free body diagram and all these equation of motion. Okay, so look at here what it is. M1, it is m1g minus m2g. Look at here, m1g will act like this, which will tend the system to pull down in this side, and m2 will also act like this, which will also tend to pull down the system in this way. Okay, and both will this m2 will tend to rotate this pulley in this way clockwise, and m1g will tend to repeat this pulley in anti-clockwise, as m1g is greater than m2g. So torque due to m1g will be greater, and so pulley will be rotating in anti-clockwise direction. Okay, so acceleration will be this much. Now look at how much unbalanced force acting on the system. If you consider tension, then tension can be considered as internal force for whole the masses and pulley system. These tension T1 and T2 can be considered as internal forces. If you check external forces, then M1G and M2G. So net unbalanced force on this system, if you calculate net unbalanced force on this system, then it will come as M1G minus M2G. So what it is? M1G minus M2G. And what is M1 and what is M2? M1 and M2 is to be inertia. M1 and M2 is to be inertia. Inertia of which M1 is translating only, M2 is also translating only. So M1 is translational inertia, M2 is translational inertia, and I by R square is to be called as inertia of rotation or rotational inertia in the system. Okay, so this result can be generalized as acceleration A equal to net unbalanced force. Net unbalanced force divided by translational inertia. Total inertia, we can write it as a total inertia of the system. Total inertia of the system. And that total inertia can be written as net unbalanced force. If we write acceleration A, then we have to write net unbalanced force. Net unbalanced force divided by translational inertia. Translational inertia. Translational inertia plus rotational inertia. Rotational inertia. Remember, m1 m2 is translational inertia and I by r square is rotational inertia, and m1 minus m2g or m1g minus m2g is net unbalanced force, or we can, according to this statement, we can write A equal to m1g minus m2g, that is net unbalanced force. It is net unbalanced force divided by translational inertia. Translational inertia is m1 plus m2. And what is rotational inertia? I by r square. And this result, this concept can be get used in so many situations, in especially in questions like body in combined motion. Okay. So we can use this concept in so many situations rather than these three questions. So I can show that also. So here, if you found the acceleration A, then you can easily find out the tension T1 and T2 also by putting this value A in equation of motion. For M1, you have written M1G minus T equal to T1 equal to M1 into A. From here, you can easily write T1 equal to M1G minus A. Okay, and for T2, here we can write T2 minus M2G. T2 minus M2G equal to M2 into A. So for T2 we can write M2 into G plus A. Okay, G plus A. So we can directly use this concept also, like M1 and it is M2. So it is going downward and it is going upward with acceleration A. And if you know the value of A, you can directly write as it is decelerating. In that situation, tension is M into G effective. G effective is G minus A. If it is accelerating upward, then you can also write that tension directly as T equal to M into G effective. In that situation, G effective is to become as G plus A. Okay, so you can use this directly. You don't need to write this equation and this equation directly. If you know A and it is going downward with acceleration A, then tension here T equal to M1 into G effective. G effective will be G minus A, and it is going upward with acceleration A, then T equal to mass into G effective. Mass is M2 and G effective is G plus A. Okay, so we can write directly, and you can find out alpha also A by R, and net torque also net torque I into alpha. So I A by R, put the value of A and I, you will have the value of net torque of moment, net torque on pulley, net torque on pulley. Okay, so we have found the result. Now use this concept. What it is? Remember, net unbalanced force divided by total inertia. total translational inertia plus total rotational inertia. Okay, and use this concept to find the acceleration in this situation also. Second question is like that. You have this type of surface and on which a pulley and mass m2 here, and here will be the mass m1. Okay, so if it is rotating here, a string doesn't slip mean it will rotate and tension will be different here. So here it will be suppose T2 and here it will be suppose T1. So look at here. On system, how much unbalanced force acting? The weight of this M2G is get balanced here with normal contact force. Only M1G is acting as net unbalanced force on the system. Only M1G is acting on net unbalanced force on the system. So directly we can write acceleration net unbalanced force M1G divided by H. This mass and this mass is translating, this mass is translating only, this mass is translating only. So total translational inertia in the system is M1 plus M2, and this pulley is rotating only, and it is given the moment of inertia is I and radius of pulley is R. Then rotational inertia in the system is only I by R squared. So this will be the acceleration value. It is going with acceleration A in downward direction, and M2 will go with acceleration A in rightward direction. Okay, and if you count the value of A, then you can easily count the value of tension T. T1 will be what? M1 into G effective G minus A. Okay, and T2 will be what here? Only T2 is responsible for acceleration in M2. So T2 equal to M2 into A. And what will be the net torque? It will be accelerating in this way, clockwise direction. So angular acceleration alpha in clockwise direction will be A by R, and torque A by R. Easily we can calculate all the variable. Okay, by using the concept acceleration equal to net unbalanced force divided by total inertia on the system. Okay, and total inertia we need to remember that which body is translating and which masses is rotating. Okay, so it is translational inertia, it is inertia due to rotation. Okay, so we can solve another question also in very easy way using same concept like this. If we have questions like this, you have a pulley having moment of inertia I1 and R1, and this side have mass M1, and suppose it is a rigid support, and you have another pulley, suppose moment of inertia I2 and radius R2, and you have another mass M2. Suppose M1 is greater than M2. If M1 is greater than M2, you can say easily that this mass will go downward with acceleration and this mass will go upward with acceleration. Okay, this mass will go downward, this mass will go upward, and this pulley can rotate in this way alpha 1, and this pulley can rotate in this way clockwise direction, same sense alpha 2. Okay, so we can say that this mass will go in downward direction, this mass will go upward direction, with general observation as M1 is heavier and M2 is lighter. Okay, so by using the previous previous result, we can easily write the acceleration value. What will be the net unbalanced force? Look at M1G and M2G. This M1G will tend to bring down the whole system in this direction, this way, and this M2G will tend to bring down the whole system in this way. Okay, So net unbalanced force, as M1G is greater than M2G, so net balanced force is M1G minus M2G. So net unbalanced force. So okay, so net unbalanced force on the system divided by total inertia. In total inertia we have to calculate inertia due to translation and inertia due to rotation. Inertia due to translation means this body is only translating, this body is only translating, so total translational inertia is m1 plus m2. And inertia due to rotation or total rotational inertia, as this pulley is rotating only, so here I1 by R1 squared plus I2 by R2 squared. We can easily calculate the value of acceleration from this expression. Okay, and after getting acceleration value A, you can easily calculate say what will be, suppose here tension will be T1, and suppose here tension will be T2, and suppose here tension will be T3. So we can also calculate the tension T1, T2 and T3. For T1 you can use this equation, as T1 is acting and mass is going downward with acceleration A, so T1 will be mass m into G effective. Here G effective will be mass m1 and G effective will be G minus A. And T2 is, it is going upward, T2 is taking m2 in upward direction, so mass m2 and G effective will be G plus A. And you have the value of T1 and T2 easily, and from here you can also have value of alpha 1 equal to A by R1, and alpha 2 will be similar A by R2. Okay, so we can easily find out the value of alpha 1 and alpha 2, and from here T3 also we can calculate T3 also. How we can write T3, T1 into R minus T3 into R will be the net torque on the pulley, this pulley. Okay, so T1 into R minus T3 into R equal to net torque equal to I into alpha 1, so I into I1 it will be, and alpha equal to A by R1. We have A value, we have I1 R1 also, and we have T1 value. You have calculated the T1 value, so put the value of T1 here. Only T3 is unknown, so we can easily calculate T3 value from this equation. Okay, so you have observed this, how we can write acceleration directly. Okay, so our motto to solve this type of question, remember this formula: acceleration equal to net unbalanced force. Acceleration equal to net unbalanced force divided by total inertia of the system. Total inertia, total translational inertia, total rotational inertia. Which we have to observe this, which body is only translating, which body is only rotating, which body is translating as well as in rotating. We can apply this concept in another situation also to calculate acceleration and another parameter, like suppose you have to calculate acceleration of rolling object on inclined plane. Okay, what will be the acceleration? So just analyze this situation. This trick, this is the trick just. Okay, it is not I can't say it will be valid okay by writing equation of motion. The answer will be same, so we can apply those trick or previous trick in this question also. Look at, you have to calculate acceleration, so look at here, normal and mg. Friction is also acting, but we have to neglect here friction directly. Okay, so consider friction as this rolling object and this plane as a system, so friction will be internal. So net unbalanced force on this body, look at here, the normal force mg cos theta here, and here it in this direction mg sin theta, So only mg sine theta is unbalanced force, it looks like. Okay, so you can directly use this trick in this question also. Mg sine theta, thus this body is translating and itself it is rotating also. Okay, so translating, it is translating, this body is translating, so due to translation, translational inertia is mass m, and due to rotation we can write it as rotational inertia I by r squared, I by r squared. So a equal to mg sine theta, you can directly find this result, which is used to be get after writing a free body diagram and equation of motion and condition for rolling. But we can apply this trick in this situation also. So here m plus mk squared by r squared, and the same value will come 1 plus k squared by r squared. So if we remember this trick, net unbalanced force divided by total inertia, translational plus rotational. Okay, the same trick can be used to find acceleration in this situation also, and especially when force is acting, rolling on horizontal surface, rolling on horizontal rough surface. Okay, and force is acting on center only in this situation. Whatever be in this situation, you can also use direct net unbalanced force is this unbalanced force, external force, and if it is m, and suppose moment of inertia I and r is radius, so m plus I by r square, result will be same and in very quick time. Okay, suppose it is a solid sphere, then for solid sphere you can write I equal to, if body is solid sphere, then you can write I equal to 2 by 5 mr squared, and so I by r squared can be used as 2 by 5 m. So acceleration will be f by m plus 2 by 5 m, and this will give the result 5 by 7 f by m. The same result will come if you do the proper method. Okay, proper method means write the equation of motion for translation, write the equation of motion for rotation, and apply the condition of rolling. Okay, this result will come, and you can count this result in one step only by using the same concept. And remember, when force is acting on this center only, if force is acting here or here, then result will not will come in this way. Okay, for that we have to derive another formula also. I'll show you in another video. Okay, and if it is not a solid sphere, if it is a disc, then in that case I equal to 1 by 2 mr squared, and it is I by r squared equal to 1 by 2m, then you have to put this value 1 by 2m, and that will be the result will be 2 by 3. If you do the same question in the conventional orthodox method, then you will have this result, and you can have, without writing equation of motion, the same result: net unbalanced force divided by total inertia, translational, the same body is translating and same body is rotating. So in translation m, and in rotation inertia will be I by r square. Put the value. Okay, so you will have the value of acceleration exactly the same. So remember this trick, acceleration equal to net unbalanced force divided by total inertia, and in this type of, when rolling on horizontal, then if force is acting on this center, then only this formula can apply. Remember. Okay, so here I am going to stop this video. I hope you have understood this concept, and I'll see you again in next video with next concept, with in next topic or any another chapter. Okay, so thank you so much. Namaste.